I will show you some basic tools which are used for reverse engineering. And if you have been in contact with some bigger businesses, there are oftentimes requirements for application to pass penetration testing. These tools are usually used for penetration testing. Okay, thank you everyone for coming here today, because I came here from Czech Republic all the way down to there to show you how to hack and how to protect React Native applications. My background, my professional background is reverse engineering and penetration testing of mobile applications in general. So I created this presentation to show you various concepts, how to hack basically any mobile application and how to protect against such activities. So don't worry, this presentation won't be about encryption and other technical hard stuff, but this is something I like to call a practical security. So back in the day, I had the opportunity to interview a friend of mine whose application was hacked. He created an application which was initially small, a few users. It was aimed at the disabled users, and the application got really popular. So he evolved with this project matured, and at one moment there was really big community of disabled people who loved this application. Suddenly someone hacked his application, removed his payment gate and even replaced it with his own. So suddenly his application was not popular because there was a free or spyware enabled clone, and his profits, as he expects, it used to be 1/4 of what it used to be. So this had a direct business impact on his operation. This is motivation for what I do. On the internet you can find a lot of discussions, for example Reddit and elsewhere, where people complain about their loss or about their security issues, which are not related directly to cryptography, but simply that their application was somehow hacked, someone used some secrets from their applications, someone misused their applications or lured their users for some unwanted operations. So this is a real deal, and so people or developers like us don't know what to do about that a lot, because yes, you can do some authorization, authentication, and what else? So the what else part is what you will see today. Some common attacks and risks and solutions. One of common issues is that the device may be rooted. This may lead directly to loss of your application's data or some other hasty activities, and some mitigation for that is using root detection. Then there is a bigger area, which is complex reverse engineering, which can lead to loss of your application logic. For example, if you have some expensive machine learning algorithms, or you simply want to hide how you do something against others, and other things which can be lost or extracted from your application this way. For this case, you need to employ some kind of RASP technology, which you will see later, and you also need probably some code obfuscation or encryption of data, etc. Then you have attacks like man in the middle, where someone is in between of your application, your client, and your backend. So in that case, you need to employ some kind of certification pinning and other techniques, which I will show you at the end, called app attestation. Then there are hooking attacks. Those are similar to threat as routing, because hooking is oftentimes used to manipulate the runtime of your application to extract the secrets, and the flow of application can be changed so the attacker can see things you would like to hide. Of course, your application, as I told you in the first case, can be stolen and turned into some like spyware or ransomware. Your users may be like victims of such an activity. So your application can be really hacked and you have to do something about it. And you will also see how to steal JOT token from application. From what I've seen recently, there was like 26% of applications that lack data protection. 40% of applications use nowadays vulnerable encryption, and 81% of applications, 64% of that site is lack of code protection, especially which is dangerous if it's financial application. So applications are not well protected against hacking. To understand what hackers can do is I will show you some basic tools which are used for reverse engineering. And if you have been in contact like with some bigger businesses, there are oftentimes like requirements for application to pass penetration testing. So these tools are usually used for penetration testing. So if it's reverse engineer, it's like some black hat or he's just a white hat hacker, these tools will be probably used against your application. I'm talking today mainly about Android world because it's more easy for me. So if there are specifically iOS developers, I won't be talking about iOS as much as I do about Android. So one of the first technologies which is needed for Android device to be like rooted, so an attacker can proceed with his operation, is Magisk. Magisk is a rootkit which is like installed by the reverse engineer himself to enable root operation on device, so he can extract your app's data and do whatever he needs. Because this routing basically breaks the sandboxing of Android environment. Because usually on Android device, every application has a restricted space where it can operate, but thanks to this routing, attacker is able to do whatever he needs. The Frida is a hooking solution. That's like a framework used to write simple JavaScript snippets which can manipulate runtime of your application. So this is also useful technology for attacker. I will skip this mundane technologies. APK tool. This one is used to open APK. So it also works for ABB and other formats of Android applications. So attacker basically grabs the APK, which is, for example, delivered through Play Store, and this will enable him to reconstruct what it's made of, because APK is basically a zip file. So this will open the application and reconstruct some kind or some parts of the application, so it's easier to decompose later. Mobile security framework is really good. This is open source technology where you just drag and drop the application and it will do a basic reconnaissance of your application, so you can easily see if there are like some issues, security findings, if there are some hard-coded secrets, and basically it will give you a lot of hints about the state of your application from the other perspective. So I use this daily almost, and I have to say that this tool, albeit open source, is like a top-notch, and a lot of commercial products is trying to mimic this technology nowadays. One of the real hacking tools is a Lucky Patcher or its alternatives, which are, I know these screens are really small, so don't worry, you don't have to read the small text, just listen to me. So this Lucky Patcher is used to remove some verification checks from your application and, for example, remove advertisement, so you won't get your money from the advertisement. And I will skip this. Guidra, I won't be working on this level today, but this is used whenever you need to work with a binary code. So if you have some C++ code which is turned into machine code and you need to get one step back to understand what was originally hidden or written in the code. HBC tool is specifically for JavaScript and React Native applications. This is used to again decompile the compiled code back to the readable state. So this specifically is React Native related technology, and it's used to see what was your original code before it was minimized and other things. And I'll skip this one. Okay, so what's your application, or what's interesting in your application, as you probably know, is that you have some DBs with data you wouldn't like to share probably. You have some keys, you have some shared preferences, you have some user profiles, some configurations, and other assets which you are trying to hide against the world, because you basically believe that they are hidden because they are in the sandbox environment, which isn't true because attacker doesn't have this sandbox environment and is rooted. For example, there is an example, again, don't try to read it, of shared preferences I extracted from one really popular gaming platform which stored a lot of really interesting data in its shared preferences. And as I will show you in a second, shared preferences are really easily readable and can be easily located. Because I believe that you don't usually possess a rooted device and you haven't tried to do so. So I will just quickly show you how to read some shared preferences. On a rooted device, I have this total commander. I will grant it rooted permission. And now I can see in its data slash package name directory, there is everything your application has on Android. So it is shared prefs, and here are shared preferences. I don't know by head which one of it was, but I believe it was the first one. For example, in this application, I can see, I don't know, you don't see, but I can, that there is a Firebase user and token. So basically, if attacker or other possible approach, like some third-party dependency which got rogue, tried to navigate there, it would be able, it could just grab this JOT and then try to impersonate this user. So this way can be, for example, user impersonated. So you get some network calls on your backend, but you don't know if it really is user or someone else trying to pretend it's user. So this is how you can find shared preferences. It's that easy. You may still argue that there are no rogue devices, or as I said, there are already. But I have a few examples which will show you that there really are various vectors. For example, first two is device rooted by user, like he obviously did it. But oftentimes there are rooted emulators. Those are used for gaming, and if you know BlueStacks or Nox Player, LD Player, these emulators are just like one you've seen, and those are rooted by default. So if like these emulators were trying to do some nasty things, they could. So if a user is tempted to use your application on an emulator which is rogue, your application can be hacked. The third category is malicious third-party dependencies, because of course some of your dependencies you basically don't check third-party code, right? Or is there anyone who doesn't trust any code? And okay, so you don't read every code of every package you included in your application. So if such an application, if such plugin or whatever it is tries to go a rogue way, this plugin has access to your internals of your applications. For example, you include some really nice graphical library, but this library will at the same time steal those tokens. So that is really simple, and you have nothing to do against that. And of course, the system on Android can be oftentimes like lacking some security protection, because device manufacturers don't care enough about updating devices, so those devices may be vulnerable. And of course, also there's a hardware level. For example, there was some dirty cow exploit or rooted emu exploit some 2 years ago. So these hardware attacks are possible, and they usually lead to privilege of escalation of privilege. So with such an attack, you have nothing to do against that. So in case of shared preferences, as I said, try not to use them if you really need to store something sensitive. There are other options like Reg native keychain or Reg native encrypted storage, and these are a lot better because they use key store or keychain on iOS, or encrypted shared preferences is another option. So there are better options than shared preferences. But again, if you use some third-party plugins which already use shared preferences, for example Firebase, so we will see it, it's easily extractable. I promised to show you a repackaging attack in the introduction. So repackaging attack is the thing where you take application, open it, do something with that, and then ship it to your users like some free clone or something like that. So this will give you power to in the process to inject some code into it, of course. I have a lot of interesting techniques I like to present. For example, injection of code into main activity. You are React Native developers, so you probably know that on Android there is some main activity part of application which then starts whole, for example, web view, or I don't know what's the state of React Native on Android today, but these part of Android ecosystem are still there. So this is place where you can easily inject other code. Of course, you can, as an attacker, add some fake browser intent, so your application will open immediately some login page, and the user will think that it's still your login page and will be this like phishing attack. I will show you simple how it looks. I need one command to open application, this command, don't try to read it again. So application is opened. Now I can locate a part of application, for example, main activity, where I will add some lines of code, which will, for example, then steal some JOT token or other hasty stuff. And then I will just pack application again, and I need 4 commands for that. I need 4 commands to create application again, and I have a malicious clone of your application. This application looks like an APK. Everyone can download it on internet and try it against your users as some malwareized application. Now the really interesting part is how to steal Firebase Auth Token. I put Firebase there because everyone knows Firebase, so it will be like easily understandable. But this technically works with any JOT authentication system. So with Firebase, you add Firebase to your application. I used this on a Flutter app, but on React Native it's the same. I created some simple application with login page and logged myself into this application. And the moment you put your credentials in, the Firebase will return a JOT to your device. So the moment I'm logged in, the JOT is there. So I can, this is my authentication created, my account. I can again, as you've seen previously, open the application and visit the place where the shared preferences are and steal this token. So this is the same place as you've seen before. And here is the token. It's the long part of code in the middle. When I copy it out and show you in a JOT.io debugger, you can see that there is everything about me. There is my email, there is that user ID, and I think that's everything which is usual in JOT. So this way can anyone impersonate your users or do whatever he needs with your spoofed account. Well, now I will move a little bit further. What kind of data are sent in and out of your application? During this process, I'm going to man-in-the-middle attacks. So in the process, your application can reveal attacker what's the API architecture of your backend. It can reveal some URLs, HTTP address, bearer tokens, and JSONs in the process. So I will show you how such a man-in-the-middle attack looks like. I used a BMV application. That's the application used to control your car if it's BMV. So this application has a lot of interesting buttons. It allows you to control like your trunk, if you want a remotely open trunk, horn, lights, other things. So this application is like a control center for your car. So it's interesting target for attacker. Again, I inspected the application, opened it, checked how it looks inside, and then I set up my burp suite and connected my device, emulator in this case, to this burp suite so I could intercept the network traffic. Again, I needed to do these 4 steps and I was done. So in burp suite, you know the logo, I connected this application, as I said, and you don't have to read it, but every HTTP request is like stopped in the process. I can read it, find interesting information, and then pass it further. So every request application did is then stored in this burp suite, and I can inspect everything. And this way can someone intercept what you send from your application to your full chain of such attack. As I was talking about, is that someone, for example, repackages your application, then spreads it amongst your users, and then exfiltrates all those JOT tokens, and then can do impersonated calls against your backend systems, and you would know nothing about the origin of these calls. So I have a whole video on this topic. If you are interested, I can give you a link afterwards. But I will now move a little bit further, and that's about protection side. Speaking of protection, there is an OWASP Mobile standard, and this list is a little bit older because no one did a newer one, but it still holds. And the parts I will be talking about is M8 and M9. Those are code tampering and reverse engineering. So MSVS, Mobile Security Verification Standard, it's one thing basically, defines some 3 layers of security. The bottom one is like a standard security, like use authorization and authentication. Then there is some defense in depth, where are some like higher requirements on security. And then there is the highest resiliency against reverse engineering layer, which is required for financial applications and, for example, healthcare industry. So whenever there is like a real need to protect. So yes, there's some example. I'll skip that. The technology, or the acronym of this technology, is RASP. Runtime Application Self-Protection. Self-protection, you got it. So application has to defend itself against the rogue environment, and I will show you this technology. It's used for DRM licensing, IP protection, as I said, and most importantly, it used to be really costly. So what you will see now today is free RASP. Has anyone of you heard about free RASP already? It's 3 months old, so I think that's quite okay. So at Talsec we developed this RASP commercially, but we decided to create like a free version which is scaled down but still gives you some kind of protection, and in a lot of ways and in a lot of areas. We created this for free initially for Android and iOS, but there was it was really popular, so we decided to move this technology and enable it for other hybrid platforms like Flutter, Cordova, and the newest one is React Native, which is mainly the reason why I'm today here. So this React Native plugin I will show you is, as I said, 3 months old only, but the technology behind it is like 8 years old, or 8 years of constant development old. Nowadays we have like 1,000 of actively used applications, and I don't mean like 1,000 of instances, I mean like really different applications which already installed the free RASP in any version. So this free RASP is already actively used and we are very proud about that, and I'm gonna show you the free RASP. So if you navigate to talsec free RASP on GitHub, it's easy to find. You will see there are other sub-repositories for other flavors if you would like to. So in the case of React Native, we have a whole README which will guide you through the installation. But what's important is that we thought that the installation should be easy, and we scaled down the needs to only a few steps which are needed. So I will skip obvious installation of plugin, of course, and some iOS installation. And in case of application, you will only need to import free RASP, this hook, and you will need to configure its configuration, which is needed to like bind free RASP to your application, so the free RASP will know what's the certificate hash of your application, your watcher mail, you will see what's the watcher mail, and some like needed identifiers for iOS. And with this you will be able to configure callbacks, and those callbacks are basically privilege access callback, which will get called whenever free RASP will detect that the device is rooted whichever way. We support every kind of routing. If it's debuggable, the application, so if an attacker tries to connect with debugger to your application, it will be visible to you. Also, some customers needed to see if the device is an emulator. As I said, it can be, for example, important for game developers when they need to spot whether there is some cheater using some emulator with some auto-aim mods and other things cheaters would like to do. So then there is, of course, application integrity, which will get broken whenever someone tries to repackage your application or something like that. So this integrity will be called. Really interesting part is to check if your application is installed from official store. So for example, you support just Play Store and App Store, and you wouldn't like to see if your application was installed from APK Mirror or APK Pure or other third-party mirrors, or where someone else could upload your application and modify it in the process. So this way you can lock that applications come only from the trusted sources. Then there is hooking and device binding. Again, device binding is interesting because there is possibility to grab the application with everything, move it to different device and inspect it there. So if the application gets like this unbound from device, and for example some reverse engineer tries to inspect it in a more suitable environment, so this bounding can be detected against. So we added a callback for that. Then we added secure hardware callback. As you've heard from guys previously, there is something called secure hardware or key store, keychain, and other technologies which are under this hidden, like for example Titan chip or things like that. Because I don't know if you know these stats, but usually like 80% of devices come with secure hardware, so you can really use these keychains and things. But there are still like 20% of cheaper devices, like Android devices, Android tablets, terminals, payment systems, which don't have at all this technology, so they can't use this secure storage. So this is also important to know. And of course, we added some obligatory check for passcode if there is a screen lock or something like that added, and if there are some obfuscation issues, because sometimes users forget to turn on ProGuard. You know, ProGuard, that's the thing that will manipulate your code. So we added a check for that also. So these checks are all part of the free RASP, and you just need to add it to your dependencies. Okay, it is. Just install it as usual, and then in your application you will use free RASP and configure it. How it looks, it doesn't look in any way because there is no UI provided. So I created some application here. So now you can see free RASP in action. We will give it some heat up time. As you can see, it already found that the device is rooted. It's a rooted emulator with Magisk. It found that it's obviously emulator, and it should find also, yes, that I installed the application from origin, which is unexpected, and that the device has no lock screen because it's an emulator, and that, of course, emulators don't have hardware-backed key store. This UI is my creation. I'm not a designer, so sorry for that, but you can implement whatever you need. Like, you usually won't like to tell this thing to users. You may warn users that, oh, this device is not good for usage of this application, but it's mainly for you, so you can log it on your backend and then decide what to do next with such instance. But if you have some banking application, I guarantee you that every banking application in Europe has RASP already installed, because I think that this is necessary because PCI DSS standard requires that. So if you have some banking application and install it on, for example, emulator, you will maybe see some warning like this device is not suitable for usage, and the application will definitely silently log this incident to some logging backend. So in the case of free RASP, we provide this technology for free as is with some simple reporting. You will get on your watcher mail, I think this is bi-weekly, you will get a report of your application fleet, or like collection of signals which were seen during the time. And we also deliver this technology in a much more sophisticated way to commercial customers. Yet you could say that this is like a cat and mouse game, and it really is, because this RASP technology always tries to find something, some rooted user who has much higher privileges than we do from within the application. So, like developers of hiders, which is how this technology of hiding root is called, are always one step ahead of us. We still have to like find new ways how to detect things. So this constantly needs like some changes, updates. So this technology is evolving quickly. So we always have to evolve. For example, last time I needed to update root detection because the Magisk updated its way how it's initialized. So I had to do like 3 months of research to find a new way how to detect this simple thing. Still holds that the security should be always started from the server side, that you can't guarantee 100% security from application side. So RASP can be cut off. Someone can write some hack which will cut off this RASP part, and people do that constantly. So in that case, what to do next? So you have seen like basic, which is free RASP, then we have something which is business RASP, which I skipped today, and still I say you that it's possible to bypass. So what to do next? So for this case, we already developed a app attestation technology called Epicrypt. This will allow us to protect against things like API abuse, botnets, fake registrations, brute force attacks, man-in-the-middle attacks, session hijacking, DDoS attacks, and JSON injections. So I will show you how this technology, this attestation works in general. We also like to call it like a device and app and integrity proof for backends. So you need something which will tell you that your application is okay and that your API is talking to a legitimate target, and you need to somehow create this secure channel between these two parts. And yet I've shown the RASP, which is only part of your application, and this second part is missing. So to create this whole channel, we created Epicrypt, which is a technology which originates in this RASP on your device and transfers all the signals to your backend the most secure way we know of. So we basically collect all these signals of unwanted behavior on your device in our TALSEC RASP, and then we transfer these checks somehow, which is a magic, to your server. Your server can be like a node server, it can be on whichever cloud, AWS, Firebase, whatever backend you use, but we will deliver you this information to your server side and without any latency. The latency of this operation is like 10 milliseconds or something like that. So there is no network latency, which is oftentimes a problem because you need to do enrollment of device, like first install and evaluation of environment as quickly as possible. So we created it so it's fast, it's like really precise, and it just works. So with this Epicrypt, we will check the device on a first run. So you start application and we do the checks, everything is checked and sent back as like first information, like first incident report, and this is called enrollment of application. And then further your application is constantly monitored, and whenever there is something bad, you get information. You can use it, for example, for step-up operations. So, for example, if you have payment application, you have to do checks again whenever application decides to do some payment transaction or some other sensitive transaction. So it has a lot of usages and it's really great. For example, we recently received Ernst & Young Cybersecurity trophy for this technology. I was today really quick. So thank you for being such a nice audience. I am really glad I could be here with you. I hope I've shown you something new. Definitely you can try the free RASP, that's for free. And if you have any questions, just give me those. I will try my best to answer, and thank you.